All right, first three, determine arithmetic, geometric, or neither. So on the first one, it looks like we have, they're all perfect squares. Really, if I look at what I'm adding, I added 3, and then I added 5, I added 7, I added 9. There's a pattern, but it is not a constant, and we are not multiplying by the same thing over and over again. So it must be neither arithmetic nor geometric. Second one, looks like I'm adding 1/3 over and over again when making it arithmetic. And the third one, looks like I'm not adding the same thing over and over again, but I am multiplying by the same thing over and again. If you're not sure what the R is, take a term and divide it by the term before it. So divide 6 by 8, and we get 3/4 or 0.75. And then to check that, check like 9/2, divide it by 6 and see if you get the same thing. Take 27/8 divided by 9/2, you get the same thing. Over and over again, we're multiplying by 3/4, so it is geometric. Find the indicated term and its arithmetic. Here's our formula, first of all. Which I didn't use those formulas, but you're welcome to if you want. Instead, I know that the slope is -2 since that's the d. And then, so I'm subtracting 2 over and over again. So if I work backwards, I'd have a 0th term of 7. That means that's what the y-intercept is, if you will. Or if I plug in a 1, I need to get 5. So plug in a 1, -2 times 1 is -2. I need to add 7 to that to get the 5. So there's the rule. So now find the 23rd term. So I take -2 times 23 plus 7. So we get -46 plus 7 is -39. We can also, I can do it on this one. If you want to use the formula up above, we can certainly do that. I know my first term is 15. I'm looking for the 47th term, so 47 is the n value. And it looks like I'm subtracting 3 every time, so -3 is my d. So now I have 47 minus 1 is 46, and 46 times -3 is -138. And so I'm doing 15 minus 138 gives us -123. Nth term. First term, sorry, looks like I'm adding 22, so that's my slope. So I'm going to have to subtract 15. Or if I worked backwards, subtracted 22 from 7 to get my 0th term on y-intercept, it'd be -15. This one, I do know my slope is 9, and I know that when I plug in 6, I have to get 22 as an answer. So if I do 9 times 6, I get 54, and I need to get 22, so I must have to subtract 32 to get there. So that's the y-intercept. Arithmetic means between 7, and there's 3 blanks. And then we end up with 67. So I know if I started with 7, I added d 4 times, so there's 4 steps along the way. I ended up at 67. The difference between 67 and 67 was 60. I added 60 in total. I divided that into 4 steps, and I see that I'm adding 15 each time. So let's go ahead and add 15. So start at 7, add 15, we get 22. Add another 15, we get 37. Add 15 again, I get 52. And those are my 3 arithmetic means. Some formula is this. So looks like on number 9, we don't know what the n value is. It says a sub n, and we need to know what n value is. So I would start off with my arithmetic sequence formula. I know -29 is the nth term. I know a sub 1 is 3. I'm going to go ahead and use the formula here. I don't know what the n is, but I do know we're multiplying by -2. So we can go ahead and solve this. So 3 plus 2 there is 5. So I now know that that was the 17th term. A sub 17 was -29, if you will. And we know that n is 17 is important for our formula. So let's find the sum of those 17 terms. 17 times 3 and -29 combined together and averaged. So we get 17 times that we get -221. Next one, I see there are 9 terms. It goes from the first to the 9th term, so that's 9 terms total. I need my first term, so we plug 1 in right here for the k. 2 times 1 is 2, minus 15 is -13. That's the first term. And then also need my last term, which is the 9th term. Tells me 9 is the last one, so plug that in. 2 times 9 is 18. 18 minus 15 is 3. So plug our numbers into our formula. So -45. We don't know which term this is in the sequence, so similar to our problem number 9, we need to figure that out. So -36, I'm just using my sequence formula. First term is -1 times d. It looks like I'm subtracting 3 over and over again, so d is -3. I might subtract my 6 right away here. So -3n plus 3 is equal to -42. Subtract 3, I get -45 equal to -3n, so n has to be 15. So I know that a sub 15 is -36. So let's use our formula. The sum of these 15 terms is equal to 15 times the first and the last averaged. So -225 looks like. Now we switch to geometric sequence. Here's our formula. So we're looking for the 6th term. So 1/2 ends up being taken to the power of 5, which is really 1/32 times the -64. So we get what, -2, yeah. On this one, we're looking for the 9th term. First term is 1. Looks like we're multiplying by -2. So that's to the power of 9 minus 1, which is 8. So -2 to the power of 8. 256 times 1 is 256. Write a rule. First term. Looks like I'm multiplying by -1/3 to the power of n minus 1. Number 15, it doesn't tell me what the first term is, and I need to know the first term. So what we can do is plug 48 in for a sub n. We don't know the first term. We know that r is 2. That'd be to the power of n minus 1, and n is 4, so 4 minus 1, or just 3. So 2 to the 3rd is 8. So you can divide by 8. See that a sub 1, or the first term, has to be 6. And so now I can find The rule a sub n is equal to the first term times r to the power of n minus 1. So 6 times 2 to the n minus 1. 2 geometric means. We've got 6, and then there's 2 blanks, and then 16/9. Since it's geometric, I know I'm multiplying by r over and over again, so 3 times. So I started with 6, I multiplied it by r to the third, I multiplied it by r 3 times, and I ended up at 16/9. So I would want to divide by 6, which is the same as multiplying by 1/6. And so I can simplify this a little bit. So now r to the third is equal to 8/27. And so to solve this, I need to cube root that. Since it's an odd root, I do not need plus or minus. Cube root of 8 is 2, cube root of 27 is 3. If I had that in decimal form, that would not have been as nice. So good thing we kept it in fraction form. So now I know I'm multiplying by 2/3. So I started with 6, I multiply that by 2/3, and I get 4. Multiplied by 2/3 again, I get 8/3. And multiplied by 2/3 again, I get 16/9. 16/9 we already had. I only had 2 geometric means. I knew that term. So there we go. Some of this series. So here's our formula. So we got 6 terms. The first one. Get kind of a nasty numerator. I would encourage you, I would like to have my answer in fraction form. So if you're using a calculator, I would recommend using your fraction function. If you're using a graphing calculator, that's alpha and then the y equals, or alpha f1. So that way you can use the fraction function. That's going to make it maybe slightly more easy to simplify this. And so I'm going to do it, and it looks like I then have to divide by -4, because my denominator is -4. And so I get an answer in fraction form. It's kind of nice that way, 7,812/5. On the next one, I can see that there are 7 terms. It goes from the first term to the 7th term. I'll need to know my first term, so we just plug 1 in for the k. So 4 to the 1 is 4, times 3 is 12. And I also know that r, it's the number that gets raised to the power, so that would be 4. So 4 is my r value. So the sum of these 7 terms is equal to 12 minus 12 times 4 to the 7th over 1 minus 4. So take your numerator and we'll divide it by -3. 65,532 would be our sum. And this next one, we're going from terms 3 through 8. We want to include both 3 and 8. So if you subtract them, you get 5, but add 1, you get 6. So 6 terms there total. We're multiplying by 1/2. That's the r value, because that's the power, the number raised to the power. And then my first term is actually what I get when I plug in when I plug in 3, because it tells me to plug in 3 first. So we have to plug in 3. So 1/2 to the third is 1/8. 4 times 1/8 is 1/2. So plug those into your formula. Sum of these 6 terms is equal to 1/2 minus 1/2 to the power of, 1/2 times 1/2 to the power of 6, all over 1 minus 1/2. Fraction button on your calculator is going to be your friend here, because I'd like exactness in the answer. Okay, so as I plug this all into the calculator, oops, takes a little while to do that. Especially as I use the function, the calculator, or the fraction function rather. oops, I get an answer of 63/64 when it's all said and done. Okay, and now we switch over to stats. We've got some numbers to enter in. The outlier, the number that doesn't really fit, that's what an outlier is 100. It's way different. And so I need to enter these numbers into the calculator. I have a 28, a 20, 25, another 28, 100, another 25, and another 20. And so when I include that outlier, I get a mean, that's the X bar on the calculator, of 35.14. The median on the calculator, that's just MED. You have to scroll down one, but you get 25. The mode, it doesn't tell you what the mode is, but that's what's most frequent. Actually, I have three of them, 28, 25, and 20. They each happen twice, and then there's a single 100. The range is the difference between your max and your min. It tells you the max, and it tells you the min, so just subtract them. In this case, it's 100 minus 25, which is 75. The standard deviation, that's the sigma, looks like a cursive O, about 26.65. And then they want us to recalculate the stats without the outlier. So just go delete the outlier out of your statistics and then calculate them again and write them down. This time my mean is 24.33. My median is 25. Your mode, notice when you take out 100, now everything happens twice. 28 happens twice, 20 happens twice, 25 happens twice. So really nothing is more frequent than others. So this time your mode is actually none, even though you didn't lose any of those, just that everything's the same. Your range now goes from 28 to 20, so that's a difference of 8. And our standard deviation is 3 point, to the nearest hundredth would be 3.30. So describe the effects the outlier has on measures of central tendencies. Central tendencies are the mean, median, and mode. So what does it have for a difference? It has no effect on the median. It could have a small effect. In this case, it had none. Typically, it has no effect on the mode. This is kind of a rare occasion because everything happens in frequency, so we kind of lost our modes. But really, center outlier really has no effect on that, and it has a small effect on the mean. So sometimes it'll affect the median. It doesn't really ever affect the mode. This is kind of the only exception, but I still would really say it's no effect. And the mean does change a little bit. The other tendencies or measures, these are called measures of dispersion, like how far the numbers are spread. Those are affected greatly because we had a much larger spread when we included the outlier. They didn't ask that in this question, but that's how we would answer it if they did. All right, normal distribution. We know that smack dab in the middle is our 18, and then we're going by 3. So 21, 24, 27. If I work backwards, 15, 12, and 9. They say between 18 and 21. That is 34% of the data. I hope you have those numbers memorized. You need to. Between 12 and 18, that's the 13.5 and 34 added together. That's going to be 47.5%. At least 21 means 21 or more. At least means it could be more. So we have to include 13.5, the 2.35, and the 0.15. Remember that those two together make up 2.5. So 13.5 plus 2.5 is 17%. 16%, sorry. At most 12 means 12 or less. So you have to include the 0.15 and the 2.35, which together makes up 2.5%. Now we need to use z-score. We have a mean of 50, a standard deviation of 5. Remember our z-score formula, I'll write it down here, is your number minus your mean divided by your standard deviation. So here I have to take 50 minus the mean of 50 divided by the standard deviation of 5. That's going to be a 0. So we have a z-score of 0. Sorry, got announcements, so ignore this. 0. Staff meeting at 3:25 in the meeting center. Thank you. All right. Sorry about that interruption. So we got what, 2.4 here. So probability that z is less than or equal to 2.4. So find 2.4 now. So we get 0.9918 or 99.18%. I'll take it as a decimal or a percent. I don't really have a preference one way or the other. So we got now 34. We need to find the z-score there. I'll get negative 3.2. This, though, notice, oops, I should say z, not x. This, notice it's asking for greater than or equal to. So we're going to have to take 1 minus whatever the table gives us. So negative 3.2 is right here. So when we subtract that, we get 0.9993, or 99.93%. And then lastly, we use 56. So that z-score is 1.2. This is another greater than or equal to. So since it's greater than or equal to, we're going to have to do 1 minus positive 1.2, 0.8849. So we get 0.1151. That's supposed to be a 1 there, or 11.51%.